Hi everyone, I am Shreyas Tejas and today I am here to present a topic for 3 minutes for the PATN competition by IET. And I've chosen OOP in CPP, and I feel that is one of the. Okay, let's just get started with the PPT. So yeah, I feel it's one of the what do you say basic topics that I can go with. It's like one of my root subjects, one of my base subjects. So revisiting it and summarizing it, I just feel good, and I feel that's one of the things that I can actually convey and send the message across. So let's get started with this presentation. Basically, what is OOP or object oriented programming? So it is a programming paradigm, or what do you say, a dynamic that uses objects to represent and manipulate data. It emphasizes on actually five, but the main ones are three, which is encapsulation, inheritance, and polymorphism. But in reality, if you expand and analyze, there are two more that you can add to the list, which is data hiding and data abstraction. So total five. Let's say data hiding, data abstraction, polymorphism, inheritance, and encapsulation. But today we'll be focusing only on three, which is encapsulation, inheritance, and polymorphism. OP always allows for code reuse, modularity, flexible, a multiple variety of advantages. So why not just dive into all of those concepts? So first one is encapsulation. Encapsulation is basically what you say, wrapping the text and what do you say, wrapping everything together. Like literally means encapsulation to encapsulate in coding paradigm it means in practical it's like a class helps to represent that, and that's because we combine and put together the functions and variables like the data members and member functions are put together into one class, thus giving us an encapsulated class having everything that an object should have, the behaviors and the properties. That is called encapsulation. I'll just quickly see what is data hiding and data abstraction, even though it's not in the PPT. Data hiding is basically, only presenting what both data hiding and abstraction kind of, it's very similar, just a small difference, but basically both of them implies the same thing that we should only present whatever is required to the user and whatever is not required should be hidden from it. Like let's say, I'll give you a word example. We have a switchboard, and then are we like showing every user who on or off the switch the entire circuitry that goes behind it? No. We're just using only the on off. That's it, two functions, and that's the only thing visible to us. So which makes the life of the user a lot easier and less complicated. So the same thing we're doing in coding, and we are using classes and their properties to implement that. In coding we'll use three parameters: private, public, and protected. Three public access specifiers, which when we dive deeper into it you'll understand. But so that's what we use to provide data hiding and abstraction. Moving on to the next one, inheritance. So inheritance is a process of creating a new or cloning a new class from an existing class. The new class inherits all the properties and methods of the existing class. And in CPP we use a colon to as a syntax, and it has lots of what do you say advantages like code reuse, promotes modularity and flexibility. Like I mean, all of the main advantages of using OOP itself. So that's inheritance. Basically, it's like a parent class and a child class. So like how in reality, also just think like we as children inherit our genes from our parents, and those genetics define our DNA, our genetic structure. The same thing happens with the parent class, whose what do you say? Let's take DNA or properties or whatever you want to say are inherited by the child class, and then from that it develops and creates its own unique identity, but still maintaining its genetics inside. Moving on to the last one of the most important properties of OOP, polymorphism. Polymorphism, literally, the word means the ability of objects to take many or multiple forms. So it is one of the behaviors that allow CPP to achieve virtual functions, function overriding. But one of the main and common uses of it in coding that we see in everyday life is function overloading, or what do you say, operator overloading. Let's go with function overloading, which is the base, like which is the easiest to understand. So function overloading is like two or three or how many functions you want can have the same name, but just with a different what do you say parameter list, or like the formal parameters. Actually, that the parameter list will be different. Like it can be different in the sense of what do you say, maybe the number of arguments or like the type of arguments. So I'll give you a small example. Let's say we are creating a calculator using functions, and instead of putting add 1 2 3 4, which is very hard and like which will confuse us in the later, we can just define one add and give the same name for all the functions, be it addition, subtraction, multiplication, or like or different types of adding. Let's say we are adding two integers, we are adding two floats, we are adding three floats. So we can name all of them add only, but in the parameter list, we can differentiate it as like add then int a, int b. Next one can be add float a, float b. Next can be add int a, float b, int c, like that. So that way, when you actually call the function, just call it add, and depending upon the parameters given, it will automatically correspond and call the function, which makes our life a lot easier with OOP. So that was one of the other main functions of polymorphism. Now coming to the best practices to code in OOP with CPP is that, just avoid using global variables a lot. So start using smart pointers, because pointers is one of the basic concepts of CPP, and just start using OOP in general. Just start using classes, because that is what made C into C++, that transition. So just remember to, manage memory properly, and avoid memory leaks, and just flush out garbage, not needed garbage variables, and just stick to like small these good practices, which will help you in the long run. Now, moving on, in conclusion, I would just say mastering OOP in C++ requires a deep understanding of key concepts and best practices by using encapsulation, inheritance, polymorphism, also data hiding and abstraction. But the main ones are encapsulation, inheritance, and polymorphism. You can write a code that is modular, flexible, and efficient. By following best practices, you can ensure that your code is easy to maintain and extend. Thank you for attending this presentation, and I really hope I was able to send the message across. And thank you.